So, hi everyone. Today we will see the drugs acting on central nervous system. Drugs acting on central nervous system in medicinal chemistry. Okay. So, we will complete this topic in 9 different lectures because it is a little bit lengthy topic. So, we have to complete in different lectures in short like 20 minutes, 25 minutes. Okay. So, in the first one, drugs acting on CNS. So the first lecture will be sedatives and hypnotics. In second lecture, antipsychotic agents. In third lecture, antidepressant agents. In fourth lecture, we will study anti-epileptic agents. Again, in fifth lecture, we will study general anesthetics. Next, in sixth lecture, we will study local anesthetics. In seventh lecture, we will complete opioid analgesics. Opioid analgesics. In eighth lecture, we will complete anti-Parkinson agent. In ninth lecture, we will complete anti-Alzheimer agents. Okay. So in this 9 lecture, we will complete the whole topic, that is drugs acting on CNS. Now let's start with the sedatives and hypnotics. So these sedatives and hypnotics are, simply you can say, non-selective antidepressants. They decrease the overexcitation, they reduces the overexcitation, or so they are non-selective antidepressant. In these, sedatives will be having low doses and hypnotics will be having high doses. Okay. This sedative reduces stress and overexcitation without inducing sleep. Without inducing sleep. Whereas hypnotics reduces stress and overexcitation with inducing sleep. This is very important point. Which one induces sleep and which one doesn't induce sleep. Okay. Next thing is that these sedatives will be having low dose, whereas hypnotics will be having high dose. Okay. Next, the classes of different classes of sedatives and hypnotics. So there are 12 different classes of sedatives and hypnotics, and they are: number one, barbituric acid derivative; number two, benzodiazepines; and their derivatives. Next, number three, pyrazolide pyrimidine. Next, number 4, imidazolide, pyrimidine. Imidazolide, pyrimidine. Next, number 5, cyclopyrrolone, pyrrolone. Next, number 6 is piperidinone. Piperidinone. Number 7 class is piperazine derivative. Okay. So after that, class 8 is parasympatholytics, and class 9 is carbamate esters. Class 10 is chloral derivative, and class 11 is miscellaneous. Now we will see the different examples. Okay. For example, in class 2, one question came in 2023 GPAT. So in this, what is the position for nitrogen? So two nitrogen atoms will be there in benzodiazepine, and in this, see, benzodiazepine. So dia means two and aza means two nitrogen. So what will be the position? The position will be 1 and 4. So the position will be 1 first and 4th position. Okay. Next, in class 3, pyrazole pyrimidine. Example will be Zelpam. Zelpam. In this, one pyrazole ring will be present and one pyrimidine ring will be present. Two ring will be there. One pyrazole ring and one pyrimidine ring. Pyrazole ring is 5-membered ring and pyrimidine ring is 6-membered ring. Okay. Next, class 4, imidazoline pyrimidine. Example will be zolpidem. Example will be zolpidem. Okay. In this heterocyclic ring will be one pyridine and one imidazole. Two ring will be there, one pyridine and one imidazole. Pyridine will be 5-membered ring and imidazole will be 6-membered ring. Okay. Next, class 5. That is cyclopyrrolone. Example will be zopiclone. Example will be zopiclone. And class 6 is piperidinone. And the example for piperidinone will be glutathamide. Glutathamide. And in this, the rank will be piperidine and having functional group ketone. Next, class 7, that is piperazine derivative. So in piperazine derivative, the example will be hydroxyzine. Hydroxyzine drug. Okay. Next, class 8 is parasympatholytics. Class 8. Parasympatholytics example is scopolamine. Next, class 9, that is carbamate esters. And the example of carbamate esters will be meprobamate. Meprobamate. Next, class 10 will be chloral derivative, and the example will be chloral hydrate. Chloral hydrate. Next, class 11 is miscellaneous, and the example of miscellaneous will be disulfiram. Disulfiram is very widely used. In this, aldehyde dehydrogenase inhibitor is the mechanism. Disulfiram mechanism is aldehyde dehydrogenase inhibitor. I forgot to tell you one more class, that is class 12, and it will be serotonin precursor. Serotonin precursor. Serotonin precursor. And the example of serotonin precursor will be L-tryptophan. L-tryptophan. Okay. Now we will see the SAR of barbiturate, that is structural activity relationship of barbiturate or barbituric acid derivative. One thing I must say, that the different classes or classification of barbiturate will be there. That is long acting barbiturate, short acting barbiturate, and intermediate acting barbiturate. We will see all the classes of barbiturate derivative in the pharmacology lectures. Okay. Now we will see the direct SAR, that is most important, structural activity relationship. This is very, very important SAR. So before going to learn about SAR, first of all, we have to know the structure. So what is the structure of barbituric acid or barbiturate? In this, you have to remember that three hydrogens or two nitrogen and three ketone group will be present. Three ketone functional group will be present and two nitrogen will be present. These two nitrogen group will be present at 1, 2, 3, 4, 5, 6. That is 1 and 3. 1 and 3 position. Sorry, this is not visible. Wait, I'll write here again. So write a benzene-like structure. In this, two nitrogen will be present and three ketone group will be present. The numbering will start from anti-clockwise direction. 1, 2, 3, 4, 5, 6. Now see, the two nitrogens are present at which position? Important point. Two nitrogens are present at first and third position. Numbering will start at anti-clockwise. Next more important point is that cyclic amide. So this is an example of cyclic amide. Why cyclic amide? Because in this nitrogen is present. So this is an example of cyclic amide. Next, three ketone groups are present at which position? Three ketone groups are present at 2, 4 and 6 position. So 2 nitrogen at 1 and third position. 3 ketone group at 2, 4, 6 position. Okay. Next, you have to remember that this is also called barbituric acid and it is also called barbiturate. Now see why it is called barbituric acid. Because in this, like one structure is there, if you see. So now what will happen? These here two hydrogen are there, yes or no? So from this rearrangement will take place and one hydrogen will go there. So ultimately the final structure will be like this. Like this. And here one hydrogen will be there and remaining on like this. So because of this one, it is called barbituric acid. So one OH will be there, C double bond O will also be there. Okay. So this double bond will be going there. So here will be two double bond, two bond, one OH and one double bond O like this. Because of this, it is called barbituric acid. What is the IUPAC name? The IUPAC name of the barbiturate is hexahydropyrimidine hexahydropyrimidine 2,4,6 trione. 2,4,6 trione. I hope you got it. You can also say that 2,4,6 trioxohexahydropyrimidine. In this, pyrimidine is the main heterocyclic structure. Pyrimidine. Okay. One most important merit is that this barbituric acid is less active. Why? Because of the presence of two hydrogen at fifth position. Due to the presence of two H plus at fifth position, it is less biologically active. Okay. Now we will see what are the different modification can takes place. So the first modification that can takes place is that the modification on keto group at C2, C4, and C6. So due to the modification at C2, C4, and C6, that is ketone group, pharmacological activity of barbiturate will reduce. For example, if the ketone group is or carboxyl group is replaced with C double bond S, then what will happen? Pharmacological activity will reduce or decreases. First point. Second point is that if the carboxyl or carbonyl group is replaced by C double bond S, that is thiocarbonyl group, then what will happen? They act as general anesthetics. They act as general anesthetics rather than of sedatives and hypnotics. Second point is that modification on nitrogen group at C1 and C3 position. At C1 and C3 position, the alkylation on nitrogen atom at first and third position leads to decrease in the pharmacological activity. So alkylation of nitrogen at C1 or C3 will lead to decrease pharmacological activity, or you can say decrease activity. This is the second point. Next, third point is that, listen, in this, phenobarbital is more active when compared to methylbarbital. So this is the reason. Next, in the third point, modification on fifth position. That is, in fifth position, two hydrogen atoms are there. So if two hydrogen atoms are present at fifth position are modified, those compounds having less pharmacological activity, then what will happen? See, at C5 position, two protons, that is two hydrogen, both are unsubstituted. Unsubstituted. Then what will happen? Very less pharmacological activity will be there. If monosubstituted, monosubstituted means one is substituted, then what will happen? Less pharmacological activity will be there. If both the two are disubstituted, that is both the two are substituted, then what will happen? High activity will be there. High activity will be there. So if the fifth position is substituted with two alkyl groups, then what will happen? The pharmacological activity will increase. Okay. If you feel watching my video is worth it, then please subscribe my channel. Okay. Thank you. We will see in the next lecture. We will meet.